In this video, we're going to talk about examples with the shell method. So I'm going to give you 4 examples here, and hopefully that will give you some idea of how you do this. Okay, so in example number 1, we're given that y is equal to x minus x cubed, and y equals 0, and x is between 0 and 1. I'm rotating around the y-axis. So that means I'm rotating around the y-axis, looks like this, and I'm told that x is between 0 and 1. So it means my cross-section is going to be vertical in this situation. So, putting it all together, the volume here is equal to 2 pi between 0 and 1, because I'm integrating with respect to x, I'm using x bounds. My top function, my bottom function, my top function is this, my bottom function is that, so I'm going to equal x minus x cubed, and then you end up with minus 0, and then the radius in this case, since you haven't shifted the axis, and you're integrating with respect to x, it's just going to be x for the radius, dx. Okay? So going through the process, you end up with 2 pi integral between 0 and 1, and you have x squared minus x to the power of 4 dx, and then equals 2 pi, and then you integrate that, you have x cubed divided by 3 minus x to the power of 5 divided by 5 between 0 and 1. So that's going to, you put the numbers in, you have 1/3 minus 1/5, so you end up with 2 pi multiplied by 2 over 15, which equals 4 pi over 15 units cubed. Okay, that's going to be the volume for this question. Okay, in example 2, x equals e to the negative y squared, and then x equals 0, so in that case your top function, your bottom function, and I'm restricted between y is between 0 and 1, and rotating around the y-axis. The y-axis is over here, rotating here. The cross-section is going to be parallel to the axis of rotation, so it's going to be horizontal. So that means I'm integrating with respect to y. So, setting it up, we have v is equal to 2 pi, integral between 0 and 1, because that's what we're told. And then my top function, my bottom function, my top function is this, my bottom function is this, in that case e to the negative y squared. And then, since I'm integrating with respect to y, my radius is y, since we haven't shifted anything. Okay, so y dy. So, putting in the math, so set this as u, so in that case we have 2 pi. And since u is equal to negative y squared, du dx is equal to negative 2y, u of 1 is equal to negative 1, u of 0 is equal to 0. So that means my integral is going to be, substitute everything in, you end up with e to the u, and this becomes negative pi, and this ends up between negative 1 to 0. And by integrating the negative, flip the signs, you end up with pi times 1 minus 1 over e. Okay, so in that case, this will be my volume for this question. Okay, so these are examples where you just integrate with respect to x and y, depending on the axis of rotation. And example number 3, we're going to talk about when you do a comparison between the washer disk method and versus the shell method. Okay, most things you can actually just go ahead and do either. But there are times where you probably prefer to do one over the other. Okay, so let's go ahead and draw this diagram. So y equals x squared plus 1, my diagram looks something along the lines of this, and between 0 and 1 and 1, so in that case, I'm bounded over here, x equals 1. Okay, so in that case, plug in 1 times 1 squared, and end up with 2. Okay, so now I am revolving around the x-axis, the y-axis for this case. We're running the y-axis over here. That means because I'm doing washer disk and washer method, you have to do perpendicular, the cross sections are. And then you realize that, oh crap, now we have 2 sections, 2 regions in this question. Okay, because we have upper bound, lower bound chains, and this is R1, this is R2. Okay, so in this method, you end up with integral, the volume is equal to pi integral between, in this case, I'm integrating with respect to y, so I'm going to use y bound, so between region 1, yeah, let's go to region 1. So region 1 is equal to integral pi between 1 to 2, from 1 to 2. My top function, my bottom function, my top function is 1, so in the case 1 squared minus my bottom function is going to be, you already write that now, right? So in that case, you have x squared is equal to y minus 1, so x is equal to the positive component of y minus 1. So in that case, you have y minus 1 squared dy. Okay, so doing region 2, you end up with pi between, again, from 0 to 1. Okay, this is a solid, so in that case it's just going to be a disk. So in that case it's going to be 1 squared dy. Okay, so again, you can just go ahead and integrate this. It's going to be the region, the volume is going to be R1 plus R2. That's going to be total volume for this question. And I think the answer comes out as, let me just copy the number down. The answer is 3 pi over 2. Okay, 3 pi over 2. Now, if you use the shell method, you'll see very quickly why this is preferred. Okay, so let's go and draw a diagram again. Okay, this is my function, and this is between 0 and 1. I'm rotating around the y-axis. Okay, and that means because I'm rotating around the y-axis, my cross-section is going to be parallel to that, so that's going to, you're going to have to integrate with respect to x. Okay, so now between 0 and 1, so that means my volume here is equal to 2 pi integral between 0 and 1, and then my function here, top function minus bottom function, top function is this one, bottom function is that one, so you end up with x squared plus 1 minus 0, and then I am integrating it with respect to x and I have not shifted anything, so that means my radius is just going to be x. Okay. Okay. So if you go through the process, you end up with the same answer. Okay. You can go ahead and do it, and you'll realize that the answer will be the same. Okay. I'm not going to work this out because of the duration of this video. So convince yourself. Okay. Which one is easier? Shell method is easier because you can just integrate with just one function, one integral, and you're done. With this one, you have to break it up. Okay. Now, in the last example, we're going to talk about the cases where shell is necessary. Okay, shell is necessary if you cannot get y by itself, okay, or get x by itself, depending on the situation. Okay, if you can't isolate it, then you have to do the shell method. Okay, so in this case, I have this given function x cubed minus plus x plus 1, and bounded by y equals 1 and x equals 1, and then rotate around the x equals 1. Okay, so in that case, I'm bounded here by 1, so in that case, I have bounded over here. So in that case, this is the region of interest, this triangle over here, this triangle looking thing. Okay, so I'm rotating around x equals 2. Okay, so I'm rotating around here. So using that idea here, that what we have is volume here is equal to, okay, let's talk about the cross-section. The cross-section is going to be horizontal, vertical in this case, because it has to be parallel. Okay, so if you look at this, if you do wash and disk method, you can't isolate y. You can't isolate x because you just can't do it. Okay, so that means this one here only can be done using the shell method. Okay, so in that case, my volume here is equal to 2 pi between, in this case, between 0 and 1. Okay, and then my top function in this case is this one. My bottom function is y equals 1, so I end up with x cubed plus x plus 1 minus 1. Okay, and I am integrating with respect to x. That means my radius will be in terms of x. So you have to think about this. This is in terms of x, right? So in that case, this distance is going to be controlled based on how far it is away from the axis of rotation. Okay, so that's going to change. Okay, so x in this case is going to be from 0 all the way to 1. So in that case, the maximum width is going to be 1. So in that case, it's going to be 2 minus x. 2 minus 1 is 1, which is you right here. 2 minus 0 is 2. So in that case, you end up with here. So in that case, you're only looking at this distance. So that means my radius for this one would be, I think I'm running out of space. So let me write it here. The volume is equal to 2 pi between 0 and 1, x cubed plus x plus 1 minus 1 up. And then I have my bottom function in this case. My radius would be 2 minus x dx. Okay? So the answer comes up with this question as equal to 29 pi over 15. Okay? So that's the situation for this question. Okay? So in all, what you have to think about is when you do the show or disc method, pick the one that's easiest. So if you have to break it up, just go with the one that you don't have to break up. That makes it easier. Okay. So on the AP exam, they don't explicitly want you to. Well, they don't explicitly say that you have to learn the show method, but I'm teaching you the show method so you have a different plan of attack depending on how you want to approach the question. Okay. So that is that. Okay. Thank you.